Bluetooth Audio and Data 101 Learning in 5 minutes.
Why Bluetooth? The purpose of Bluetooth is to provide cable replacement between commonly used devices by using wireless radio links. Some of the goals are low cost, low power, short range. WHO controls Bluetooth on specs. Bluetooth Special Interest Group, Ericsson Technology Licensing, Founder Member, Intel, Founder Member, Lenovo, since 2005, Microsoft since 1999, Apple, since 2015, Nokia Founder Member, Toshiba, Founder Member, IBM, Founder Member, currently 30,000 plus members. Bluetooth types. Trivia time. 2.1 EDR was officially launched July 2007. This applies to audio. The ISM band. Bluetooth operates in the industrial, scientific and medical ISM band, roughly 2,400 MHz to 2,480 MHz. The ISM band is available worldwide. Devices operating in the ISM band are unlicensed under certain radiated power requirements, plus 20 dBm EUFCC plus 30 dBm. Many other devices use the ISM band, 802.11b and 802.11 grams, ISA 100 traffic, cordless phones, wireless stereo headsets, microwave ovens. Radio power classes. Class 1, roughly 100 meters 20 dBm nominal. Class 2, roughly 10 meters 8 dBm nominal. Most smartphones use Class 2. Class 3, less than 5 meters. Computer mice, health devices etc. Bluetooth uses frequency hopping spread spectrum. Frequency hopping avoids conflicts with other devices. Bluetooth divides the ISM band into 79 channels, 40 channels with BLE 4.0. Channel selection is performed such that all 79 channels are used, approximately, equally. Bluetooth SIG state 20 channels minimum must be used to be compliant to BT standards. Radio frequency usage conflicts with other devices are avoided since Bluetooth uses pieces of the ISM band small amounts at a time. Frequency hopping spread spectrum. Information about the master device determines the channel selection sequence. The master's unique device address, Bluetooth device address or BDADDR, is one of the components in the channel selection sequence. The master's internal clock, Bluetooth clock, is another component of the channel selection sequence. The two components taken together provide enough randomness in the channel selection sequence that a reasonable number of Bluetooth picanotes can operate in the same physical space. The master's Bluetooth clock is rarely on the air, so the frequency hopping provides a measure of security. Picanote example below. Note only one frequency sequence is used. Adaptive frequency hopping, AFH. AFH is used to allow Bluetooth to adapt to the local operating environment. When using AFH, devices determine channels that appear to be unreliable. The devices can then agree not to use the unreliable channels. AFH allows Bluetooth to avoid channels where transmission is unlikely to succeed, improving throughput since those channels are not even tried. Cooperate better with other wireless technologies by not transmitting on frequencies that another device is using. Bluetooth chipsets perform spec analysis before assignment, which is a Bluetooth standard. Unreliable channels take time to recognize and that can be programmed into devices. Channels. BT 2.1 EDR link. SCO channel. S are defined audio pipes with higher priority than ACL channels. ACL links are used to pass application data and radio-to-radio control messages from one device to another. Basic data rate ACL links are limited to approximately 720 kbps based on a 1 Mbps data rate. Enhanced data rate (EDR) ACL links provide up to 2.16 Mbps based on a 3 Mbps data rate. ACL links are used to pass application data and radio-to-radio control messages from one device to another. Basic data rate ACL links are limited to approximately 720 kbps based on a 1 Mbps data rate. Enhanced data rate (EDR) ACL links provide up to 2.16 Mbps based on a 3 Mbps data rate. Two EDR-capable devices will monitor the packet error rates between them and adjust the transmission data rate and packet sizes to minimize the amount of data received with errors. Audio links, SCO, synchronous connection oriented, and SCO extended SCO, links are commonly used for audio transmission. Audio quality is roughly the same as that of the public telephone network. SCO links provide guarantee time slots. SCO links use larger packet sizes than SCO, allowing more audio information to be transferred in a single transmission. This allows SCO links to also support retransmission, something that is not available in SCO. Audio over ACL. The Advanced Audio Distribution Profile A2DP, provides for the streaming of high-quality audio over ACL links. Audio compression algorithms such as MP3 or SBC reduce the bandwidth required for audio. Device addressing. Bluetooth device addressing uses the IEEE 48-bit MAC address format. Each Bluetooth device has a unique address known as the Bluetooth device address. The upper 24 bits are an organizationally unique identifier, WI, assigned by the IEEE. This is commonly referred to as a BDADDR. Firmware can just use lower 24 bits for working and thus only work to a group of addresses. Syntax: XX, 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 XX. Masters and slaves. A Bluetooth master is a device that initiates a connection to another device. A Bluetooth slave is a device that accepts a connection from a master. A device that is not currently connected is neither a master or a slave. A Bluetooth network consists of one master device and up to 7 slave devices. This is called a piconet. When a device participates in more than one piconet, a scaturnet is present. Masters and slaves. The master device provides timing and access control for slave devices. Slaves do not speak unless spoken to. Slave devices only communicate with their associated master devices. Slave devices do not directly communicate with one another. After a connection is established, a master and slave may choose to trade places. This is referred to as a role switch. Device discoverability. Bluetooth devices may be placed into a mode where they periodically listen for a request to locate nearby devices. This is referred to as inquiry scanning. A device that is not inquiry scanning will not receive the inquiry request and is therefore invisible to the device discovery process. When an inquiry request message is received, the device responds with its BDADDR, Bluetooth clock, class of device and some other information. The class of device is a rough description of the device and can be used to filter away devices that are not of interest. Inquiry scanning. Inquirable and discoverable are often used interchangeably. Bluetooth profiles. Profiles are used at the application level as a way of specifying high-level functionality. The profile specifications define the rules and messaging required to implement a particular application client or server. Serial Port Profile, SPP, also known as TCS 710 standard, used in serial port profile devices. Wireless serial cable emulation, commonly used for cable elimination between devices using asynchronous serial communications. Roles: Device A, the device that initiates a serial port connection. Device B, the device that accepts a serial port connection. Note that Device A and Device B have no correspondence to the common DTE, data terminal equipment, and DCE, data communications equipment, terminology. Device A may be a DTE or a DCE, Device B may be either as well. Headset profiles. Headset profiles are used with mobile phones, personal headsets for hands-free phone usage, and hands-free phone systems used in automobiles. Hands-free profile, HFP, roles: hands-free unit, headset or car kit, audio gateway, mobile phone, headset profile, HSP, roles, headset, audio gateway. Duplex audio headsets that support duplex voice communication to one another or a gateway device as shown in the diagram below. VTAC extender shown, which increases range data clock reckoning, increased radio power output. DBD Athena, DBD Minerva, Segcom Liberator, 3M Pelter XP. Thanks for watching.